Hi students, in this class we are going to study about the valence bond approach, that is the valence bond theory, types of overlapping and orbital diagrams, sigma and pi bonds. First we are going to study about valence bond theory. Nature of the covalent bond can be explained by the valence bond theory. So this is put forward by Heitler and London in 1927 and it was extended by Linus Pauling and Slater in 1931. So the main postulates of this theory are first one is a covalent bond is formed by the overlapping of two atomic orbitals. So overlapping means part of one covers part of the other. So here the covalent bond is formed by the overlapping of two atomic orbitals. Next is the overlapping takes place only between orbitals with unpaired electrons. So, and another one is overlapping between orbitals with paired electrons is not possible. So this postulate shows overlapping takes place only between orbitals with unpaired electrons. And the atomic orbitals overlap to form a bond orbital in which the electrons are present with opposite spin. So the atomic orbitals overlap to form a bond orbitals, so in which the electrons are present with opposite spin. And the strength of the covalent bond is proportional to the extent of overlapping of orbitals. So the strength of the covalent bond is proportional to the extent of overlapping of orbitals. And next is the orbitals like P, T and F, which are concentrated along a particular direction overlap to a greater extent than the spherically symmetrical s orbital. So the PDF orbitals which are concentrated along a particular direction overlap to a greater extent than the s orbital. Okay, so the coaxial overlapping of orbital is more effective and forms a stronger bond than the lateral overlapping. The coaxial overlapping is known as head-to-head overlapping, and lateral overlapping is known as sideways overlapping. So here the coaxial overlapping of orbitals is more effective and forms a stronger bond than the lateral overlapping. So these are all the main postulates of the valence bond theory. Next is the types of overlapping. So the types of overlappings are, first one is SS overlapping and another one is SP overlapping and PP overlapping. First we have study about the SS overlapping. This figure shows the SS overlapping. For example, hydrogen. Hydrogen atom has a single electron and its 1s orbital. So hydrogen equal to 1s1. So the 1s orbitals of two hydrogen atoms overlap to form an SS covalent bond. So this is the SS overlapping. Next is the SP overlapping. For example, HCl. So the electronic configurations of hydrogen and chlorine atoms are hydrogen is equal to 1, 1s1, and electronic configuration of chlorine is 1s2, 2s2, 2p6 and 3s2, 3p5. So this is equal to 1s2, 2s2, 2p6, 3s2, px2, py2 and pz1. So here this figure shows the formation of sp overlapping in the HCl. So the 1s orbital of hydrogen and the half-filled 3p orbital of chlorine overlap and form a sp covalent bond. So next is the PP overlapping. For example, chlorine. The electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2 and 3p5. So this is equal to 1s2, 2s2, 2p6, 3s2, px2, py2 and pz1. Here this figure shows the formation of PP overlapping in chlorine molecule. So the three pz orbitals of two chlorine atoms with one electron each overlap to form a pp covalent bond. So this is the pp overlapping obtained in chlorine molecule. So the strength of the covalent bonds are in the order SS bond less than sp bond less than pp bond. Okay, next is the orbital diagram. So sigma and pi bonds. So sigma and pi bonds are types of covalent bonds that differ in the overlapping of atomic orbitals. So sigma bonds are as a result of the head-to-head overlapping of atomic orbitals, whereas pi bonds are formed by the lateral overlap of two atomic orbitals. So the definition of sigma bond is a covalent bond formed between two atoms by the overlapping of orbitals along the molecular axis is called a sigma bond, and pi bond is a covalent bond formed between two atoms by the overlapping of orbitals along in a line perpendicular to the molecular axis is called a pi bond. Okay, so the figure shows the formation of sigma bond and formation of sigma and pi bond in the oxygen molecule. So the oxygen molecule electronic configuration is 1s2, 2s2 and 2p4. So this is equal to 1s2, 2s2 and 2px1, py1, pz2. So if x is the molecular axis is as shown in this figure, the 2px orbitals of two oxygen atoms overlap along the axis to form a sigma bond is shown in this figure, and the two py orbitals will overlap along a line perpendicular to the molecular axis to form a pi bond is shown in this figure. Okay, so thus the double bond in oxygen molecules O double bond O comprises of one sigma bond and one pi bond. Okay, so this is the sigma and pi bond. Okay students, in this class we are all study about the valence bond theory, types of overlapping and orbital diagrams, sigma and pi bonds. We will continue the rest in the next class. Thank you.